Today we are going to see the topic database normalization, which is one of the most important topic in database management system. Now, coming to an overview of normalization, we will see here as what is normalization, what is the use of normalization, what are the various levels of normalization with certain examples. So coming to normalization, normalization is actually we'll be decomposing the tables to reduce the redundancy and the problems caused by redundancy. So what are the problems caused by redundancy? The insertion anomaly, deletion anomaly, updation anomaly, all these are the problems caused by redundancy. So to minimize these problems and to better organize the data in database in a much more consistent way, we are going with normalization. So we can say that normalization is a process of making the table free from anomalies and save space by reducing the redundant data. So this is one example for insert, update and delete anomaly. So consider this table. So here we cannot add the detail of we cannot add a new course or the detail of the course unless we have a new student enrolled here. Okay, so if a new student is enrolled, then only we can add the detail of a course. Otherwise, we cannot add a detail of the course. This is called as insert anomaly. Now, what is update anomaly? Say, for example, if one student is changing his address, then all the records which corresponds to that particular students need to be changed. Otherwise, there will be an update anomaly. Next is delete anomaly. So in delete anomaly, consider that the student Smith is moving out of college. So in that case, all the details of the course physics also gets deleted. So this is delete anomaly. So to deal with all these anomalies and to make the database consistent, we are going for normalization. Normalization generally works through a series of stages. We'll call them as normal forms. So these are the normal forms, types of normal forms. Generally, we will be decomposing the table till BCNF to avoid the database anomalies. Coming to first normal form, so we can say that a relation is in 1NF form if it contains atomic value. That means the attribute of that table should not contain any multiple values. See here in this example, if you see this table, the attribute course contains multiple values. So this table is not in 1NF form. So to change it into, so to change it in 1NF form, what we have to do, we have to maintain the table like this. So here you can see that none of the attributes have multiple values, all are single valued. So this is in 1NF form. Coming to second normal form. So before going to second normal form, we'll brush up certain other concepts, which is what is candidate key. So a candidate key is actually an attribute or a set of attributes where we can uniquely identify the record of a table. So either we can have one one attribute as a candidate key, or there can be a set of attributes as a candidate key. From this, any one of the candidate key will be termed as a primary key. Next is about prime attribute and non-prime attribute concept. So in the candidate key, we have already told that a set of attributes can be a candidate key. So in that, an attribute that is part of the candidate key is called as prime attribute, and that is not part of a the candidate key is called as non-prime attribute. That means if in a relation there is x, y and z as attributes, if x and y together is a candidate key, then x is a prime attribute, y is a prime attribute, whereas z is not a prime attribute. Next, coming to functional dependency. So functional dependency is actually a relationship between one attribute and the other attribute, where this one attribute uniquely determines the other attribute. So it is actually represented by an arrow sign. So if x and y are attributes of a relation, then this means that x arrow y means that x determines y. That means for all values of x, the y value will be same. So if you see this table, you can tell that here we have three attributes: employee name, project, and email address. So for all the values, all the same values of employee name, the email address values also is same. Okay, so we can say that employee name determines email address, or email address is a dependent of employee name. But we cannot say that employee name determines project. Why? Because for the same value of employee name, the project values are changing. So we cannot say that employee name determines project. We can say that employee name determines email address. So this is functional dependency concept. We have full functional dependency and partial functional dependency. That means it is not mandatory that only one attribute can determine another attribute. There can be a set of attributes determining an attribute. So if at all these set of values together only is determining the y attribute, then we can say that it is fully functionally dependent. If any one of that attribute is determining the other attribute, then we can say that it is partial functional dependency. For example, if x and y together is determining z, x alone can determine z, then we can say that there exists a partial dependency. If x and a combination of x and y together only can determine z, then we can say that there is a fully functional dependency. Now with this concept, we will move to the 2NF. So here a table is said to be in 2NF if these two conditions satisfies. That is, it should be in first normal form, and all non-prime attributes are fully function dependent on the primary key. That means there should not be any partial dependency existing. If there is no partial dependency existing in the table, then we can say that the relation is in 2NF form. Now see this table. Here the primary key is the combination of course ID and semester ID together. So this is the primary key. Now course ID, we know that primary key always determines any attributes in that relation. So the course ID and semester ID together can determine number of students. Also course ID and semester ID together can determine course name. But here course ID alone can also determine course name. So here occurs a partial dependency. I repeat, course ID and semester ID together can determine course name, whereas course ID alone can determine course name. So here occurs a partial dependency, and the table is not in 2NF form. So to make it into 2NF form, we have to decompose these tables into two. That is, course ID and course name can be taken out and maintained as a separate table. So here is the decomposed form. So course ID and course name has maintained as a separate table, then the other attributes have been maintained as another table. So here now this table is in 2NF form. So till now we have seen what is normalization, what is the need for normalization, 1NF with an example and 2NF with an example. Now we'll see what is 3NF. So a relation is said to be in 3NF form if it is already in 2NF, and it should not have any transitive dependency. That means a non-primary attribute should not depend on other non-primary attribute. Then only we can say that it is in 3NF form. Or we can also tell that a table is in 3NF if it is already in 2NF, and for any functional dependency existing in that table, any one of this should be right, or should suffice. Then only we can say that it is in 3NF form. That means for any functional dependency x determines y, either x should be a super key of a table or y should be a primary attribute of the table. Then only we can say that the table is in 3NF form. We will see an example here. So in this table, study ID is the primary key. So of course, primary key can determine any attribute in the table. So a study ID determines course name, teacher name, as well as teacher telephone number. But another functional dependency exists here is teacher name also determines teacher telephone number. That means for any same value of teacher name, the teacher telephone number is also same. Teacher name determines teacher telephone number here, but teacher name is a non-primary attribute. Also, teacher telephone number is also a non-primary attribute. So a non-primary attribute determine non-primary attribute. So there is transitive dependency existing here, and it is not in 3NF form. So a solution for this is to decompose this table by taking the teacher name and teacher telephone number out and maintaining it as a separate table. So here we have maintained the teacher name and teacher telephone number as a separate table, and the other three as is kept as a another table. So now these two tables is in 3NF form. Coming to BCNF or Boy Scout normal form, it is actually an extension of 3NF and a lot more stricter version of 3NF. It is also called as 3.5NF. So why is it called as a stricter version of 3NF? See here, in 3NF, the condition was in any of the function dependency x determines y, either x should be a super key or y should be a non-prime attribute. If any one of these conditions satisfy, then we used to say that, then we said that it is 3NF form. But in BCNF, in for any functional dependency x tends to a, if x is a super key, then only we can say that it is in BCNF form. In 3NF, it was like either x should be a super key or y should be a primary attribute. If any of this condition is true, we said that it is in 3NF form. But here in BCNF, in this functional dependency, x determines a, x should be a super key, then only we can say that it is in Boy Scout normal form. So see this example here, the primary key is a combination of student with the course. So this is a primary key, and yes, of course, student and course together can determine a teacher because a primary key can determine any attribute of the table. Now here another functional dependency that exists is a teacher. The attribute teacher can determine the course. You can see for the same value of teacher, the y value, that is the course value, is also same. So teacher can determine course here. So teacher determine course is another functional dependency, but teacher is not a primary key, teacher is not a super key. So here in BCNF, in x determines y, x should be a super key. Then only we can say that it is in BCNF form. Here teacher determines course, teacher is not a super key. So the relation is not in BCNF form. So for making it into BCNF form, we have to again decompose this table into two. That is, student and course can be maintained as a separate table, and course and teacher can be maintained as a separate table. So this table is in BCNF form now. So now we can see one example where we are taking one schema, one relational schema, and we are decomposing it into 2NF, 3NF and BCNF. So here is the relational schema we have taken. There is no values given here. This is a relational schema given, and here the property ID is the primary key here. So we are assuming that the relation is in 1NF form, and these are the functional dependencies given here. Now checking for 2NF. So we have already assumed this as 1NF form. We have to check for 2NF condition. So in 2NF condition, the conditions are, or the rules are, it should be in 1NF form. So we are assuming this as 1NF form. And the next one is there should not be any partial dependency existing here. So you can see here the first functional dependency one is property ID determining country name, lot number, area, price and tax rate. Yes, the primary key is property ID, so it can determine any other function in the table. Next is the functional dependency 2, where the combination of country name and lot number together is determining property ID, area, price and tax rate. So here uh, this is a functional dependency 2. Next, coming to functional dependency 3, country name alone is determining the tax rate. So in the functional dependency 2, the combination of country name and lot number together is determining tax rate, whereas the functional dependency in functional dependency 3, the country name alone is determining the tax rate. So here occur the partial functional dependency. So it is not in 2NF form. So to make it into 2NF form, we have to take out this country name and the tax rate into a separate table. So here you can see we have decomposed this table. Now the country name and tax rate is maintained as another table, and all other attributes, all the remaining other attributes are brought into another are kept into one single table. Next we have to see for 3NF. So here in 3NF the rule is the table should be in 2NF form, and there should not be any transitive dependency here. A non-prime attribute should not determine another non-prime attribute. So here if you see in functional dependency 4, area is determining price, which is a non-prime attribute determining a non-prime attribute. So here exists the transitive dependency. So the table is again not in 3NF form. We have to decompose it into 3NF form by bringing the area and price attribute as a separate table. So here we can see that the area and price is kept as a separate table, and all other attributes is kept as a separate table. So now this tables all have all are in 3NF form. Next, checking for BCNF form. Now if you see this table, the country name, which is a primary key of this table, is determining tax rate. Correct only, because the in BCNF the rule is that when if X determines Y, X should be a super key. So country name is a super key. It is a primary key, and of course it's a super key. So the BCNF condition satisfies here. Now in lots 1B table, here area is the primary key. Area is determining price. So area is again a super key determining another attribute. So this is also in BCNF. Now if we see this table, here two functional dependencies are there. One is property ID determining country name, lot number and area. Property ID again is a primary key in this table, so that's again a super key. So functional dependency 1 is agreeing the rule of BCNF. Now coming to functional dependency 2, country name and lot number together is determining property ID and area. So here country name and lot number can be considered as a super key. The reason is that the country name and lot number together can uniquely identify the record. So it is definitely a super key. So this condition, functional dependency 2 condition, also is satisfying the BCNF. So all these tables are satisfying the BCNF form. So final up to BCNF, the decomposed tables are this. So the original table we have actually decomposed it into 3, which is lots 1A, lots 1B, lots 2. To maintain the consistency in the database and to avoid all the problems caused by redundancy. So that's about normalization up to BCNF. Thank you all.